Good evening, everyone. My name is Christopher Pilang. I'm from Group CS103R, Group C, and today I'm going to do a presentation for MAT183 for topic related rates. Let's continue with the introduction. So, the topic that we chose is related rates. Is it about deflating balloon? So this is the list of my group members, and the first one is Elvis Atopiauntok. He is our leader and he's the one who in charge for all the materials that we use for this presentation. And me, Christopher Pilang, is the one who will be presenting to all of you about our topic, and Mr. Muhammad Lukmanul Hakim will be the one who editing and doing all the stuff about the video. This will be the content for our video. So chronologically, we will start with from introduction. So introduction will be briefly introduce you to related rates. So second one is objective, which is the purpose of we doing the related rates. So the problem statement will be the problem that usually happen in the real life situation that are related to related rates. So the solution will be the formula that we have found through our research and our learning throughout this year. And conclusion will be the closing of this video. So let's move on. This is the introduction for this topic. Related rates problem is determining the rate of change of a quantity that is unknown by relating it to another rate of change of quantity that is known. This can be done by using a formula that relates to the rate of change that given and deriving it with respect to time. In this case, we are calculating the rate of change of spherical balloon by using the rate that has been given and identifying which formula that can be used to determine the rate of change that has been asked to determine. After that, we derive the formula with respect to time. Hence, we can calculate the rate that is unknown. The objective that we want to achieve by doing so is to find the rate of change of one quantity knowing the rate of change of another quantity in the balloon. Second one is to identify which formula that can be used to determine the unknown rate of change, and also to derive a formula with respect to time. And lastly is to determine the rate at which the radius is changing of the balloon. This is the problem statement for this topic. A child kept an inflated spherical balloon in his room. The balloon deflating slowly at the rate of 0.5 cm³ per hour. If the diameter of the balloon is 26 cm, determine the rate at which the radius of the balloon is decreasing. Also determine the rate at which the surface area of the balloon is decreasing at the same rate. I'll bet all of you might be confused with the question just now. So actually in the problem statement there are two questions, which is the first one is the rate of radius decreasing at the rate of 0.5 cm³ per hour, and the second one is this rate of surface area which is decreasing at the same rate as the radius zone. So the left side will be the first question solution and the right side will be the second question solution. So let me explain to you the first one. So dv over dt is negative 0.5 centimeter cube per hour, which means it's decreasing due to the negative value in the 0.5. So now we are actually finding the rate of change, which is dr over dt. So now we'll be finding the formula for a sphere, which is v equal to 4 over 3 pi r cube. So r, as we know, I think it's common, which is a diameter divided by 2. So the diameter just now is 26 centimeter, so we divide it by 2, become 13 centimeter. So now we are substituting the radius just now into the dvdt, which is 4 pi r square, and dr dt. So 0.5 is our dvdt just now, equal to 4 pi 13 cube, because radius is 13, so over dr and over dt. So after we calculate all of it, the dr over dt will become negative 1 over 1352 pi centimeter per hour. So meaning the negative value indicates the decreasing rate for the balloon, you know. So the second one is we are finding the rate of surface area respect to time. So we haven't figured out what is it, but we figured that the formula for surface area is 4 pi r squared. So we are using it. We now will be differentiating it. So ds over dt will become 8 pi r dr dt, because we are differentiating it respect to time. So ds dt will become 8 pi, substituting the radius is now, which is 13, and also we are substituting the rate that we have just found in the first question just now. So it will become negative 1 over 1352 pi. We substituting all of this, then ds dt will become 1 over 13 cm cube. Cm square per hour. So now we already found both of these answer. Then I bet all of you already understand this formula. So actually related rates is one of the common problem that usually happen in the real life. So we are applying the mathematical method to solve the problem in the real life. Sadly, we are now already at the conclusion. So as the conclusion, we learned that when a balloon is deflating, the volume of the balloon and also the radius of the balloon will decrease eventually. So we also learned that related rates problem involve finding a rate at a quantity changes by relating that quantity to the other quantity whose rate of change is known. In this case, the rate of change in radius of a balloon can be determined by using a rate of change that has been given, and usually rate of change is respect to time. And for me personally, it is actually fun to learn calculus,
because calculus is something that is important to all of us, no matter whether we are in school or in work, because most of our life something need to be solved logically, and some of it might need the mathematical solution. So calculus 1 is the best way for you to strengthen your mathematical skills, so which is you are strengthening your best in calculus. I think that's all from us today. By the way, thank you for all of you who viewing this video. I hope you enjoyed it, and thank you very much. See you next time. Bye.